In this lesson, we'll learn about a testing technique called snapshot testing. Snapshot testing allows you to take a snapshot of the expected output of a component and then compare it to the actual output produced during testing. Snapshot tests are a very useful tool whenever you want to make sure that the output of your functions doesn't change unexpectedly. When using snapshots, Vitest will take a snapshot of the given value and then compare it to the reference snapshot file stored alongside the test. The test will fail if the two snapshots do not match. Either the change is unexpected or the reference snapshot needs to be updated to the new version of the result. To use snapshots in Vitest, you can use the toMatch snapshot method from the expect API. Let's look at snapshots in action using our notification toast component. Taking our first test, for example, we can create a simple snapshot test by modifying the assertion to use the toMatch snapshot method. Let's modify our assertion to use the toMatch snapshot method from the expect API. Our expected output is our dummy component in HTML format. If we run our tests, we should see a snapshots folder automatically created for us in the same directory as our tests. Inside this folder, we should see our test file with an additional .snap extension. This is your snapshot file and it will serve as a point of reference to the test we run in the future. Let's open up our snapshot file to see what's inside. Inside the snapshot file, we can see that the expected output of our component is rendered as a string. The snapshot is stored as a JavaScript object with a single key value pair, where the key is the name of the test and the value is the expected output. If we make a change to our component, for example, changing a class name, our test is going to fail. And we can see a clear representation of the mismatch that caused this failure in our terminal. When this happens, Vitest makes it easy to update the snapshot from the current state. In watch mode, you can press the U key on your keyboard to update the failed snapshot directly in the terminal. Or you can use the update flag in the CLI when running your tests to make sure Vitest updates snapshots. Since we're in watch mode, let's press the U key and watch our snapshot file update with the current change in real time. Inline snapshots are another way to use snapshots in Vitest. Instead of creating a separate snapshots file, the expected output is saved directly in the test code. This can be used for small and simple tests, where creating and jumping across different files may seem tedious. To use inline snapshots, you can use the toMatch inline snapshot method from the expect API. Let's modify our previous test for the notification toast component to use an inline snapshot. If we run our test, we can see that the snapshot was saved directly in the test code, making it easier to manage for small tests. In this lesson, we learned about snapshot testing and how to use snapshots to speed up our testing process. Snapshot testing is a valuable tool to ensure that the output of our components remain consistent over time. While snapshot testing has its benefits, it's important to note that it may not be suitable for all kinds of tests and may become difficult to maintain over time. In the next lesson, we're going to dive into testing API calls that make external requests to a server and learn about a process called mocking. See you there. In this lesson, we'll be learning how to mock REST API calls. Mocking is a technique used in software testing to simulate the behaviors of objects or systems that the software being tested depends on. This is done to isolate the software being tested from variables outside of its control, such as network connections or external services. Mocking is important in testing because it allows developers to test their code more thoroughly and efficiently. By creating mock objects or services, developers can test their code in isolation without having to worry about the behavior of external dependencies. We're going to use the JSON placeholder API to learn how to mock REST API calls. The JSON placeholder API is a simple fake REST API useful for testing and prototyping. We'll be using Axios to make our API calls, so let's install it into our project. Run the command yarn add Axios and wait for it to install. Alternatively, you could use npm. Let's get started with building out the component we'll be testing. In our components folder, let's create a new component called postcard.view. First, we import some methods from view, and then we import our Axios library into our component. Then we go ahead to create three variables: post, loading, and error to hold our state. Next, we create a fetch post function that fetches a single post from the JSON placeholder API and sets the results to our post state. We make sure to handle any errors and update our loading state accordingly. We call our fetch post function when our component mounts, and in our template, we display the post, title, and body, taking into account the loading and error states. The code for this component is available below or in the lesson resources. Now that we're done building our component, we need to decide what we will be testing. First, we want to make sure that our app successfully makes an API request and displays the correct data if the request is successful. Next, we want to make sure that our app properly handles errors by displaying an error message if the API request fails. Please note that we will be able to test these different cases without making an actual call to the JSON placeholder API server. With these in mind, we can now create a new test file in our test folder and give it the name postcard.test.js. We want to start by making necessary imports from Vitest utils, Axios, and the component we'll be testing. Let's start by importing Axios in our code. Next, we want to import the mount method from Vitest utils. Next, we can go ahead and create a mocked response for our API request. Our mocked response is a realistic example of what a real API server response would look like. Let's create a new object called mockPost, which will serve as our mocked response. Our server response has a user ID, an ID, a title property, and a body property. Now, we can start building out our test. Let's create a new test suite for our postcard component using the describe block. For our first test, we want to make sure that our app successfully fetches and displays the correct data from our API request. Before we mount our app, we need to be able to intercept the GET request made using Axios and return a mocked value. We do this because we don't want to make an actual request to the real API server. Remember, mocks allow us to test in isolation. To achieve this, we can use the spy-on function from Vitest. Vitest provides utility functions to help you with this through its vhelper. You can import V from Vitest or access it globally when the Vitest global configuration is enabled. Let's configure it globally. This way, we can use functions from Vitest such as describe, expect, and test without having to import them every single time. Head over to your Vitest config, create a new property called globals, and set it to true. Now, let's head back to testing. Our spy-on function takes two arguments. The first is an object, and the second is a key from that object. Spy-on watches that object and the getter or setter, so that when it's called, it does what is required of it. In our case, we're asking it to mock our responses with the mock resolve value once method, which is used to resolve different values over multiple async calls. We can now set our data to the mock object we created earlier, mockPost. Now that we've been able to intercept our GET request and we're sure that our test will not be making any calls to the server, we can go ahead and mount our postcard component. In a similar fashion to how we've been writing our previous tests, let's create a variable called wrapper and mount our component in it. Based on how our component works, our loading text is supposed to appear once our component is mounted. Therefore, our first assertion will be to check if our component contains the loading text. Next, we can go ahead and import our postcard component. Let's run our test to make sure that it's passing. Let's head over to our terminal and run the yarn test command. Great, we can see that our test successfully passes. Next, we want to test if our fetch post displays successfully. Since the process of fetching our post is asynchronous, we need to make sure that our promise operation has been completed before writing our assertion. To do this, we make use of flush promises, an utility method from Vitest utils that flushes all pending resolved promise handlers. You can await the call of flush promises and improve the readability of your test. Let's install flush promises into our app. Next, we can go ahead to call the flush promises method in our code. Now, let's write assertions to check for the existence of our post title and post body in our app. We're going to use the find method along with the data test ID attribute to find our post title. We opted to use the data test ID attribute to find an element in our template as opposed to the class selector we used in previous lessons. This is because class selectors may be ambiguous and change unexpectedly based on the current implementation. Meanwhile, Data test ID is a special attribute used to identify a DOM node for testing purposes. We need to ensure that its value is unique so that we do not cause conflicts between components. Next, let's check that the text of our post title in our postcard component is the same as that of our mock post title. We can repeat the same process for our post body. Let's go over to our terminal to confirm that all our tests are passing. Now that we're done with our first test, let's get started with writing our second test. For our second test, we want to make sure that our app properly handles errors by displaying an error message if the API request fails. We can follow the same approach we used in writing the first test with just a few changes to the code. Remember, we want to intercept the GET request here as well. For this test, we want to use the mock rejected value once method, which is useful to create async mock functions that would always reject. Our method is going to receive an error object as its argument, along with the error message we specified in our postcard component. Now, just like the previous test, we can mount our component, check that our loading text is displayed on screen, call our flush promises method, and write our assertion to check that the correct error message is being displayed. Let's head over to our terminal to confirm that everything works as expected. Great, all our tests are passing. By mocking our APIs, we can test our web pages more thoroughly and efficiently without having to worry about the behavior of external dependencies. This helps us catch bugs and ensures that our code is working as expected. In the next lesson, we're going to learn about E2E testing with Vitest and how to write more thorough tests for a full page application with user interactivity. See you there. In real-world scenarios, you'll most likely be writing tests that mirror a user's behavior. You want to make sure that your app functions correctly from a user's perspective. This means you need to test the entire flow of your application. So you will not only be testing the individual components, but also how they interact with one another. This process of testing is called end-to-end testing, but is commonly referred to as E2E testing. Writing E2E tests can help you detect bugs and issues that may occur when components interact with each other. Some of these issues may have gone unnoticed during unit or integration testing. In this lesson, we're going to be combining our two previous components to form a simple post app, and then we're going to write E2E tests for that app. Before we get started, let's take a look at what our app looks like. Just like a real-world app, our app contains a form that collects user inputs for a post title and body, and a button that submits this form. We're using an API endpoint from the JSON placeholder server to create our posts. To focus on testing, I've gone ahead to build out our app. The code for this app is available for you below or in the lesson resources on GitHub. This endpoint accepts a title, body, and user ID, which we generate using our getUserID function. Both inputs are required for the post to be created successfully. If the user adds some text for the post title and leaves the body empty, we display an error using the notification component and vice versa. If the post could not be successfully created, we also display some error using our notification component. Because the logic and structure for our postcard component has changed, we're also going to need to update the test for this component. Our new postcard component is fully presentational and doesn't hold any state. Therefore, we can write a simple snapshot test to assert that our component renders correctly. Let's delete our previous test and write a new test to check that our created posts render correctly. Let's create a title variable and call it test post, and then a body variable with the value of test post body. These two variables will serve as props for our postcard component. We can then mount our component using these two props as its second argument. Now, we can write a simple snapshot test to check that our postcard component displaying our posts render correctly. Let's head over to our terminal to confirm that our tests are now passing. Great! Now that we've confirmed that our tests are passing, we can get started with writing our test for our app. Remember, we're going to be testing this app like a real user. So let's list some crucial tests that need to pass for us to conclude that our app works as expected. First, we want to test that a user can successfully create a post. Next, we want to check that our app displays the correct notification based on the user input and the API response. Now that we have these in mind, let's get started with testing. Let's create an app.test.js file in our project's root directory. We'll import some important functions from Vitest utils, such as mount and flush promises. Next, we will import Axios, which will be responsible for our API calls. Then, we'll import our app component into our code. Since we already set up globals in our configuration file in the previous lesson, we won't need to import Vitest methods anymore. Now, let's set up a mock post object that will be used to fill in our post form just like a real user. Our mock post object contains properties required to make a successful post request to our JSON placeholder API. These properties include a user ID, an ID, a title property, and a body property. We can then initialize our test suite using the describe function. We can describe our test suite using something simple such as post app. For our first test, we want to check that a user can successfully create a post. We can use the same technique we used in the previous lesson to mock an API call using the spy-on function from Vitest utility helper v. Only this time we'll be changing the second argument from get to post. Next, we'll mount our app component. Next, we want to set the values for both the post title and the body. We can do this by finding the input elements for both fields and setting the values using the setValue function. Let's set the value for the post title. We can find the input element responsible for the post title by using the data test ID attribute that we set in our code. Next, we'll call the setValue function and set its value to the mock post title we created earlier. We can repeat the same process for the body field. Make sure to replace your title text to body. Lastly, we want to submit the form to create our post by triggering the submit button. Let's find our form by using the appropriate data test ID name and calling the submit event on this form by calling the trigger function. Now, let's write assertions to check that our form was submitted by checking for button text changes. Whenever we submit our form, our button text changes from create post to creating, so we're going to check for that change. We're going to find our submit button by using the type attribute and check that our HTML contains the correct text that signifies that our form was submitted. Let's also assert that our posts were created and are now being displayed on the app. Remember to call flush promises to ensure that the promise operation has been completed. Our first assertion is to confirm that our app component contains our mock post title. And the second assertion is to confirm that the app component also contains the mock post body. That concludes our first test. Let's head over to our terminal to confirm that this is passing. Awesome, that works. Let's get started with writing our next test. In our next test, we're going to try and submit our form without entering the required data. Naturally, with the way our app works, this should trigger an error and display our notification toast component with the appropriate message. We also want to check that our notification toast component displays the correct message if creating a new post fails, probably due to some network or API issues. Because our next tests are quite similar, we can group them in another describe block and nest them inside our main describe block. Create a new describe block called user gets notified for notification related tests. Our first test should check that the app notifies the user when they try to submit a form with empty fields. Let's get started with writing that. Let's mount our app component. Next, let's attempt to submit our form without filling in our form fields. We can do this by triggering the submit event on our form just like we did in the previous test. We expect our app to display an error to the user based on this action. So let's write an assertion to confirm that this error is actually being displayed. We expect our app to contain the correct error message. In our case, please input post title. To make our test more complete, we can also assert that the error notification and ultimately the error message no longer appears on our page after we click the close button. To achieve this, we will first need to trigger the click event on the close button. Before we do that, let's go into our notification toast component and add a data test ID attribute to it so that it's easier to find in our tests. In our notification toast component, we can add a data test ID attribute with the name close notification. Now we can return to our test file and find this button with ease. After we find our button, let's trigger a click event on this button in order to clear the notification from the page. Now we can write an assertion to check that the error message is no longer on the page. Simply adding a not before to contain will negate this assertion. Good. Now let's add a post title and try to submit our form again. Let's find the post title input field and set its value to the title from our mock post object. Now that that's set, let's try and submit our form again. Since we submitted our form by filling out our title field but not our body, our app is supposed to notify us of this error. So, let's write an assertion to confirm that the user gets the correct notification, which is an error message alerting the user that the body field is empty. Our app is supposed to contain the error message, please input post body. Let's head over to our terminal to confirm that this is passing. Great, now that those tests are passing, we can start writing our final set of tests. Our next test checks that the notification toast component displays the appropriate message when an attempt to create a post fails. This may occur due to an error from the API and is not necessarily the fault of the user, but it's helpful to account for all types of unexpected behavior when writing tests. Just like we did in the previous lesson, we're going to mock a rejected request and pass in an error object as its argument. Create a new test block for this test. Next, we're going to mock a rejected request. Make sure to pass in the correct error message which is specified in your app as a string. Now let's mount our app and set values for both the title and the body fields using data from our mock post object. Next, let's submit the form. Finally, we can write appropriate assertions for our tests. Our first assertion is to confirm that our submit button was triggered by checking for changes in our button text. And our next assertion is to confirm that the correct error message is displayed in our app when creating a post fails. Before we write that, let's make sure to call flush promises to ensure that all promise operations have been completed. Great. Now we can write our assertion. That brings us to the end of this lesson. As you can see, implementing E2E testing is an essential step in ensuring that your application is functioning correctly and providing the best user experience possible. It also allows you to identify and fix issues before they become major problems, and it gives you the confidence to release updates with minimal disruption to users. In the next lesson, we're going to take a look at some extra Vitest features such as the Vitest UI, adding test coverage to our app, and then we're going to discuss migrating from Jest to Vitest. See you there. To round up this course, we'll be exploring some extra features that Vitest provides, such as the Vitest UI and adding coverage to our test. We'll also be looking at the process of migrating from Jest to Vitest. Vitest provides a beautiful UI to view and interact with your test. The UI is optional and so does not come pre-installed with Vitest, so you're going to have to install it yourself. To install Vitest UI, run the command yarn add-d at Vitest UI. After installation, you can view the UI by passing the UI flag to your test command. A page should open up in your browser automatically, but if that doesn't happen, you can visit the Vitest UI at this address. The UI provides information on your test, such as the total number of test files in your project, total number of tests that are passing, total number of tests that are failing, and the total number of tests in general. You can run all your tests at once using the play button. It also comes equipped with different color modes. The UI also allows you to isolate a test file and go through each test in that test file individually. You can also search for tests in the UI. This will be helpful for projects with a lot of tests. Let's talk about test coverage and how we can add coverage to our tests. Test coverage is a metric that measures the amount of code that is executed during testing. The goal of test coverage is to ensure that all parts of the code are tested and that there are no untested or under-tested parts of the code. Vitest supports test coverage from providers such as V8 and Istanbul. V8 is built into JavaScript's native V8 engine and thus is very fast and efficient to use. V8 also provides accurate code coverage information without requiring any special configuration or setup. Istanbul, on the other hand, is a more feature-rich tool that is not tied to any JavaScript engine but supports a wide range of JavaScript testing frameworks and tools. Because Istanbul isn't built on top of JavaScript, it may sometimes lag behind on language features and can be slower and more resource intensive than V8. Both of these providers are powerful and effective tools that can help ensure that your code is thoroughly tested. They are also both completely optional. So let's look at how we can add coverage to our tests. To set up coverage in your tests, you will need to specify your provider in your config file, or V8 will be used by default. Create a coverage property in your test object, and you can set the provider to either V8 or Istanbul. For this course, we will be using V8. Once that is done, head over to your terminal and pass the coverage flag along with the test command to run your test with coverage enabled. Because test coverage providers are completely optional, they do not come pre-installed with Vitest, so we're going to have to install that ourselves. Select the Yes option to install the V8 coverage provider. Once that is done, we can go ahead and run our test again using the coverage flag just like we did before. Awesome, now we can see the result of our test passing along with our test coverage report from V8. Let's discuss how you might want to migrate your existing project that uses Jest to using Vitest. Although Vitest has been designed with a Jest-compatible API to simplify the migration process, there are still some differences you need to keep in mind. Here are a few things to note while migrating your project. In Jest, functions like expect, describe, and test are usually available by default and don't need to be imported explicitly. Vitest, on the other hand, does not have these available by default, and so we can either import them from the Vitest module or we can configure Vitest to make them globally available just like we did earlier. You also need to install any additional dependencies required for Vitest, such as HappyDOM or JSDOM for our browser environment, and V8 or Istanbul for code coverage. Also, you will need to update your test files to use the Vitest API instead of Jest APIs. For example, all instances of the Jest function should be replaced with the V function in your code. Please check out the official Vitest documentation for a comprehensive migration guide to simplify moving to Vitest. Congratulations on successfully completing this course. Just to recap, in this course, we explored the fundamentals of testing with Vitest. We learned why testing is important, how to set up and configure Vitest in our projects, and how to write tests for our Vue components using Vitest. We also learned about snapshot testing, testing API calls using a technique called mocking, and writing E2E tests that simulate the real-life behavior of an actual user. Finally, we discussed some extra Vitest features such as the Vitest UI and test coverage, and we also looked at the process of migrating our apps from using Jest to using Vitest. I hope with this knowledge you'll be ready to write robust and thorough tests for your app. For those who want to take their testing knowledge even further, please check out the official Vitest documentation and keep an eye on the Vitest repo on GitHub for more updates and information on the tool. Thank you for taking this course and good luck with your testing.